So perceptions algorithm is very useful and powerful, but it was invented in 1957. So nowadays, if you want to apply this algorithm to although this algorithm is faster than the original gradient descent algorithm for the classification problem, but it's still quite slow when you apply these methods to the real data real large data nowadays. And another problem for this algorithm, it depends on the epsilon. Oh, sorry, this has epsilon. We need to choose the learning rate. And nowadays, there is even a better algorithm doing the job faster and without worry about this learning rate. Okay. So now a faster algorithm without worry about the learning rate. Okay, so next in this short video, I just give you a brief introduction about another algorithm. It's called the maximum margin classifier. Classifiers. It's also called hard margin. Is also called hard margin support vector machine. We will learn more about the supported vector machine in the future lectures, but this is definitely a first supported vector machine we can use. Okay, so the basic idea is, suppose we have an example. We have the X feature plane, and we have the good dot. We have some data points on this side, and we have some classified not in this class cases. And by applying the perception algorithms, we can find a classifier, right? Maybe I can do it a little bit bold. Suppose we can apply the algorithm we introduced, and we find the linear decision boundary. Actually, the margin. What's the margin mean? Margin means we can extend from this decision boundary. We can extend by this decision boundary, and by searching for the maximum distance between this classification boundary to the blue dot one, and also the maximum distance to the cross this red crossed one, and this maximum margin, this is called margin. This is called margin, and this also called margin. So the idea with this classifier is we enforce. Let's make it. the constraints. So this algorithm will give us a linear classifier, but with maximum boundaries, like right in the middle, most in the middle one, and has the largest margin as possible. Okay, and by doing that, we can enforce the constraints. So yi multiply. Remember previously we say we want to have the this one the labels multiply the decision function is greater than 0, right? Greater than 0. But instead we enforce the constraints greater than 1. This is greater than 1 because remember 0 in the perception algorithm. Okay. So that's the difference. That's the difference. And recall, if from our last lecture, if this omega is a unit vector, then we know omega, this decision boundary decision function applied to xi plus alpha is the distance. Is the distance between h decision boundary and point x, xi. Okay. And if this omega, if this w is not a unit vector, if does not equals to 1, we can still standardize it. So for example, we can apply the omega over the length of the omega times xi plus alpha over omega. Okay, so this represents the distance between the each data point and the decision boundary. Recall that if we have these constraints, we apply to here. This implies because this is greater than 1, right? So this omega xi plus alpha. Okay, so if this is greater than 1, if at yi is positive or negative 1, so if I take the absolute value, this quantity will be greater than 1, and this whole thing will be greater and equals to 1 over the length of the omega. Okay, in other words, and this represents a margin distance, right? Margin distance. So among all the points, so each of the data point, the distance is calculated by this, right? And we want this distance can be as large as possible. So now we can give the algorithm. So it's called the maximum margin classifier algorithm. Maximum margin classifier algorithm, which is the idea is we want to find the omega and alpha. that minimize this omega. So if this omega is smaller, this margin distance will be increased, right? So we want the minimum of this omega, but subject to with the constraints yi, xi, decision function plus alpha is greater and equals to 1. So this is called the maximum margin classifier. But usually we give a square here because the square here give us smooth function to minimize. Okay. This is also called a hard margin support vector machine. Also called. Okay, so support vector machine. So in the future class, I just use SVM to represent the supported vector machine. Actually, this minimization problem can be solved by quadratic program. And in the lab or homework, you will see how to solve such problem. Solve the maximum margin classifier. Okay, I think that's all you need to know to solve the related questions in the homework. Thank you. That's all for today.